It's tough flying weather, but that's no problem to the man behind the controls of this airplane. He has instruments to guide him on his way, and he knows he can depend on them, fair weather or foul. For behind this dependability of instruments are the painstaking inspections of many conscientious workers. It is the responsibility of the crew chief to make certain that each installed instrument performs properly. He is charged with inspecting all instruments daily, before flight, and at prescribed regular intervals. Backing him up are the trustworthy instrument mechanics at the air depots, assembling, repairing, and testing every type and make of aircraft instrument. But this work in the air depot shops presupposes that the line maintenance crews make their inspections properly. Daily inspections include a few simple points. Use a soft, lintless cloth to wipe every cover glass. All glass and optical equipment must be kept spotlessly clean. While servicing the cover glasses, make certain that they fit tightly and are not cracked. Of course, absolute pressure-operated instruments, like the manifold pressure gauge, and other instruments, like a thermometer, should show the proper local pressure and temperature. All instruments which are lighted individually must be inspected visually to determine whether the bulb lights. Remember also to check all caging knobs for freedom of movement and correct operation. Setting knobs, too, must be operated, and the correct setting made. Before each flight, after the engine is started, the instruments are given a pre-flight inspection. Even with the engine idling, no pointer should show excessive oscillation. Each instrument must indicate a reading known to be normal and correct. An abnormal reading is a sure sign of trouble, either in the engine or in the instrument, and both engine and instruments must be right for a safe and successful flight. And when the motor is revved up, the pointer should hold fairly steadily at the readings consistent with engine requirements and speed. If the instruments show no signs of trouble during these inspections, they're fit for flight duty. Other inspections must be made at the prescribed period. The routine of these inspections, normally done in the airplane, can best be demonstrated on this instrument panel, which duplicates fairly accurately the installations in regular aircraft. The first step is to make certain that all instruments are securely held in place by the machine screws in each corner. Tighten all loose screws and replace any missing ones. Remember to use a light screwdriver of the correct size and very little pressure while doing this type of work. Check all instruments to make sure that the luminous paint is bright, clear, and unchipped. Operations markings on the cover glasses must be clearly discernible and correct. On the reverse side of the panel, check all lines and connections, and there usually are plenty on modern aircraft. If a loose connection is found, it should be tightened securely using an end wrench or a crescent wrench. Don't use pliers. All electrical connections should make good contact and fit tightly. Inspect also the vibration absorbers at the panel mounting points. They must have the proper tension, be firmly fastened, and have free movement in all directions. Bonding should be checked for good contact and security of fastening. Frayed wires must be replaced, of course. During these inspections, make any adjustments possible. In the case of an instrument failing to light up, the lamp probably is burned out. It's a simple matter to unscrew it, and from the spare lamp receptacle on the panel, to replace it. If the new lamp fails to light, check the electrical connection on the back of the instrument. If the plug and wire are in good condition, the trouble probably is a defective lamp receptacle, and the instrument must be removed and a replacement installed. To remove any instrument, loosen the machine screws which hold it to the panel while supporting it so that it will not fall. If it is self-contained, like this compass, it can be removed as soon as the screws are disengaged. The machine screws go with the instrument. New ones will be included in the package containing the replacement. This is standard procedure on any instrument. But the majority of aircraft instruments differ from the compass in that they are dependent upon proper connection to some other part of the airplane. The reverse side of any panel easily proves this point. Plenty of connections, but really there are only 3 different types. Simplest are the electrical connections. The electrical wiring system can be more easily inspected if the junction box cover is removed. Often, many wires run to one special multiple-line plug connector. This type of connector must be in good condition. Look for worn or cracked female plugs and dirty or damaged male prongs. See that it seats firmly and locks properly when in place. Another type of electrical connection involves securing this common eyelet type of terminal to the binding post with a nut. These must always be kept tight. During periodic inspections, it is wise to see that each of these connections is properly fastened. Loose terminal connections are a common source of trouble that must not be overlooked. Another type of instrument connection, such as on this chronometric tachometer, involves the principle of mechanical linkage. This connection is screwed on the drive shaft takeoff on the bottom of the instrument. This type presents few maintenance problems, other than requiring regular inspection for wear and occasional oiling. Most common is the type of connection which involves tubing, since most instruments react because of vacuum and air or hydraulic pressure. In all cases, a union nipple with a pipe thread on one end and a straight thread on the other is required to join the instrument with its tubing connection. These nipples, which make possible solderless connections, come in both male and female types. The female receives the silver soldered cone on the end of the tubing and is tightened with a cone union nut. The male must be inserted in the flared silver soldered cone provided for this type of connection. Regardless of the type, the pipe thread always goes into the instrument, while the straight and coarser thread connects to the tubing. On all threaded connections, use specification instrument thread compound. The union nipple can then be screwed into the instrument and tightened firmly with the usual gentle pressure and the aid of a small wrench. The same procedure holds true for attaching the tubing. Turn the cone union nut until it's tight. Then use the wrench to draw it up just a bit more. Sometimes special adapters are required where it is desirable to use either 2 or 3-piece solderless connections. A union nipple with coarse threads on both ends is the standard connection between 2 pieces of tubing, or between flexible tubing and the main line. But you still use specification instrument thread compound. And you still make finger-tight adjustments first. Because the instruments are mounted on shock-proof panels, free to move in all directions, all connecting lines must be provided with a length of flexible line immediately behind the instrument. A 10 to 14-inch length of pressure-resistant synthetic rubber is the standard flexible connection for metal tubing. If these are not available, emergency flexible connections can be made from a short length of this rubber tubing with standard aircraft clamps. If there's no rubber tubing, a coil in the line close to the instrument will provide the required flexibility. Now let's get the crew chief out of the way and put up a wall on which to practice bonding and anchoring. There. Now we're all set. If it becomes advisable to replace any lines leading to the instrument, be certain to keep the number of bends at a minimum, particularly in vacuum lines. After measuring off the bends required, use gentle but firm finger pressure to make each bend with the radius as large as possible. Continue to shape the tubing until it's obvious that you'll be able to run it exactly where it should go. There, that's about right. It fits, has nice, gentle bends that won't cause any trouble. The lines must be anchored securely, and each point of anchorage must be bonded properly. This type of clamp is self-bonding. Just tighten the screws and you know the job's right. The line should be anchored at not less than 18-inch intervals. The 18-inch or more length between anchor points provides the necessary flexibility. So much for connection. When a replacement instrument arrives, it may be new or reconditioned. The label will give all the required information about the instrument. You'll have to sign for it, of course. This is the Army, you know. But whether the instrument is new or reconditioned, it always will be well packed and should be treated like new. Unwrap it carefully and save the wrapping. Unless otherwise directed, the replacement must be a duplicate of the original installation. See what we mean? Twins. Except that one works and the other doesn't. Take the one that doesn't and wrap it up. But treat it gently, because it still can be repaired at the air depot instrument shop, unless it gets badly damaged during shipment due to faulty packing. To install the replacement, you'll need the new mounting screws, supplied in the usual envelope. Actual installation is simply a matter of fitting the instrument in place and tightening down the screws. Replacement of an instrument is ordered for any of the following reasons. A defective lamp receptacle, as demonstrated in the case of this compass. Dull or discolored luminous markings. Repainting dials and pointers is amazingly cheap, particularly when compared with the cost of replacing an airplane and a pilot. A cracked case is an obvious source of trouble, because dust and moisture may get inside to harm the delicate instrument mechanism, which then requires a complete overhaul. Any cracked or loose cover glass. Do not attempt to make this repair yourself. It's not as simple as changing a window pane. A broken or cracked mounting lug. This can be detected easily, since the machine screw won't even stay in place when the lug is in this condition. A defective setting or caging mechanism. This usually is an easy job for the instrument mechanic, but one fight with the instrument in this condition may damage it. Some pressure instruments, suspected of leaks, may be tested by attaching a rubber hose at the connection point and blowing through it. It isn't necessary to remove the instrument from the panel in order to make this type of test. Do you suppose the hand stuck? No, this evidently leaks and must be replaced. Here's a case where the gasket has rotted away so that the instrument doesn't perform accurately. Obviously, it's a job for the instrument shop. And so it goes. If there are any known or suspected defects in any instrument, don't hesitate to remove it. You can always replace it with a dependable instrument. And if any type of inspection is your responsibility, don't fail to check the condition and operation of every instrument. Never take the chance that nothing has happened to an instrument since the last inspection. Gremlins have a way of changing settings, breaking pointers, and loosening cover glasses. And if it's a pre-flight you're doing, remember that one of the reasons you run up the engine is to check the instrument, and with the instrument, to check the motor. When you're certain that each instrument will operate correctly and dependably, then you're ready to reach for that flight report and sign your name to guarantee that the instruments are okay. Here comes the pilot for the airplane you've serviced. He's on a tough mission, and he'll be flying through some bad weather. He'll need those instruments. Remember that when you help him into his chute. And remember, it's your good workmanship that will bring your pilot and airplane safely back.